We're going to do a few more problems as our introduction to logarithms. The key is given a logarithmic expression, log A, the log of B base A is C. That's our logarithmic equation. We automatically get the equivalent exponential, which I called my round robin. And it was A to the C equals B. So this is the equivalent exponential. So I call it the equivalent exponent EQN equation. But we're also going to be given an exponential sentence. I might say K to the M equals P, and we want the equivalent logarithmic expression. The best way to remember that is to look here and we see, and I kind of think of this as, I call it Benny. B to the E is N. Down here we get the base. Out here is the exponent. And then the number that you get from the exponential is here. So this particular exponential equation gives us the logarithm log base K of the numbers P and the exponent is M. And you can, of course, check it by doing my round robin to see that it says the same. So one thing that's going to be important is you're going to be moving between equivalent exponentials and logarithmic expressions. Another aspect to doing some of these problems, you might be asked to evaluate a logarithmic expression. So for example, suppose if I said evaluate log base 15 square root of 15. So it's very important here that you have to say equals x. Now we do once you have it equaling something, then you can do the equivalent exponential. 15 to the x equals square root of 15. And then you can proceed to find what x is. And the secret is to write square root of 15 as 15 to a power. So 15 to the x, square root of 15 is 15 to the half power. That tells us that my x is a half. So the log of square root of 15 base 15 is going to be a half. So if this problem is given, you would then say log base 15 of square root of 15 equals a half. And that would give you your answer. There are other parts that we need to know. There are some logarithms that are so important that they have different notation. I might say log of 10 base 10. This is such an important one. It's called a common logarithm. And as such, we don't have to put the base 10. We just put log 10. And it's understood that the base is 10. So when you see a log without a base, it's understood to be the base is 10. And you will see this on your scientific and graphing calculators. Another logarithm that's going to be, that we're going to have a notation for is if I say log base e of a number. E is a natural exponential. E is a number 2.7812, and it goes on and on. But e is the natural exponential, so e is the natural exponential number. And this, instead of being written log base e, we write it ln x. So when you see an ln, that means it's log base e. So it's a good idea to memorize both of these. A log without a base is understood to be base 10. ln is understood to be base e, which is the natural exponent. Another piece of information to keep in mind is if I say log base a of b is c, a, the base, can only be positive. The number can be positive, but the exponent answer, the c, could be any real number. But what you get for a and b has to be positive. This is another piece of information to memorize. So these three ideas will help us with some specific problems going ahead.